Hey guys, Mr. Wilhelm here. Today I'm here to talk about physical changes and chemical changes. Now previously we've talked about matter. Matter is anything that takes up space and has mass. Today we're going to talk about how matter changes from one thing to another. And it can change either physically or it can change chemically. Physical changes. A physical change is when a substance changes but remains the same substance. There are three examples of this: a change in size, a change in shape, and a change in state. So let's talk about the first one, a change in size. If I take a piece of paper, like this piece of paper right here, and I simply take this piece of paper and tear it into two different pieces of paper, it's still paper. I can take this paper and tear it again. It's still paper. It has changed in size, but it's still the same substance. It's still paper. Okay? Another example is a change in shape. Again, I can use this exact same piece of paper. It started off as a nice rectangle, but as soon as I tear it, all of a sudden I have an irregular shape. Okay? It's a change in shape. So this would be a physical change. It's simply taking the paper and changing its shape. It's still paper. Another example I have right here is a baseball bat. You can take a tree, which is wood, and you can carve it into a baseball bat. It's still wood. I simply changed the shape of the tree. I changed the shape of the wood, but it's still wood. Another example of this is a change in state. Water is the best example, or H2O is the best example of this. Here I have H2O, water. This was a liquid water. Okay? Here I have ice. Ice is H2O. It's simply frozen H2O, frozen water. Okay? And then down here I have water being turned into a gas. There on the hot plate, as you see steam rising from this water, I'm taking water, and right here is water vapor. It's water in a gas state. Now, any way you look at it, whether it's liquid water, frozen water, or gas water, and again we use the words H2O, any one of these, it's still H2O. It's still water. It has simply changed state from a solid to a liquid to a gas. A little bit more about changes of state. Okay? There are four changes of state, or four states of matter. We have a solid, liquid, gas, and the last one right here, which is plasma. Okay? First off, a solid has a constant shape and a constant volume. Ice being the solid. Constant. It means it stays the same. Okay? If I hold this ice, I pick it up, I can set it down here on the table. Okay? It still remains the same size. Okay? It also remains the same volume. Okay? No matter what I do to it here. Now, that's a little bit different from a liquid. A liquid has a variable shape and has a constant volume. So, for example, here I have a beaker with 1,000 milliliters of water in it. The water takes on the shape of the beaker. Okay? It has a cylinder shape. If I take this water and I pour it into a square pan, the water is going to have a square shape. If I take the water and pour it into a rectangular pan, it's going to have a rectangular shape. So the shape of the water is going to be variable. It's going to change shape depending upon its container. However, it's going to continue to have a constant volume. Its volume is going to stay the same. If I have 1,000 milliliters of water in this beaker, and I pour it into a square pan, it's still going to be 1,000 milliliters of water. If I pour that water into a rectangular pan, it's still going to be 1,000 milliliters of water. So here the water has a variable shape, but a constant volume. Lastly, we have our gas. Okay? Gases have a variable shape and a variable volume. Okay? Gases will take on the shape of their container. So for example, I have my, again, boiling water down here, And I don't know how well you can see that, but you could have water vapor that's coming off of this boiling water. Okay? In that case, the gas is taking on the shape of the room. But also the gas is expanding. It's not staying right here. The gas is moving outward, and it will continue to move outward. It will continue to expand as it takes up the room. Okay? Lastly, we have our last category, which is plasma. Now, plasma is a little bit different from all three of these because plasma is kind of in a category of its own. Plasma is a very high energy state of matter. You find that in lightning. You find plasma in fire. Okay, so here, this right here is plasma. Okay, a little bit different from a solid, liquid, or a gas. That is plasma. Okay, so let's talk about how we have these physical changes in state. Okay? First off, we have a liquid to a solid. Okay? And a solid to a liquid. If something changes from a liquid to a solid, it's called freezing. Now, we all know that if I take water right here and I put it in the freezer, it'll turn into ice. It'll go from liquid water to solid water. It'll go from liquid H2O to solid H2O. But that's not the only thing that freezes. Here I have a candle. If I take this candle and I light this candle, okay, the candle will start to melt the wax, okay, and I can drip the wax onto the paper, okay. Now, as soon as the wax cools, it will go from a liquid to a solid. That's freezing. It doesn't necessarily have to be cold for it to freeze. Right now, the wax has changed into a solid. It stays on the paper right here in a little puddle. Okay, solid puddle. All right, this is a solid. It has frozen. At the same time, obviously, when I take that solid and I turn it back to a liquid, it's called melting. Here I'm melting the wax. Okay, I'm taking the solid wax and I'm turning it into liquid wax. Okay, you do not necessarily have to have heat, a lot of heat, in order to melt something. Sometimes you can simply take a piece of ice and you can leave it out on the table and it'll melt and turn into liquid water. Okay, so going from a liquid to a solid is freezing, and going from a solid to a liquid is called melting. It can happen with water, it can happen with wax, it can happen with metal. Okay, all of those things go from solids to liquids and liquids to solids. The next type of state change is going from a liquid to a gas or a gas to a liquid. Okay? First off, if something goes from a liquid to a gas, it's called vaporization. Okay? Going from a liquid to a gas, called vaporization. Again, I have my beaker of boiling water right here. And I've got the liquid water turning into water vapor or a gas. This is vaporization. Going from a liquid to water vapor gas. Now, the other part of that is going from a gas back to a liquid. This is called condensation. Condensation, going from a liquid back to a gas. Condensation. We have condensation that occurs all the time. Clouds are a result of condensation. Okay, I could take my beaker and put it over, and you're going to see it fog up because I have water that is condensing inside this beaker. And I can eventually take this beaker and the gas, and as it condenses, it will start to form water droplets. It will go from a gas back to a liquid. And you can see that water will start to build up along the rim. Water will start to build up along the rim, and then I might get a couple drops of water to fall off of there. Okay, so now I'm taking gas and turning it back to a liquid. Okay. Now, let's talk about chemical changes. Chemical changes is when I take a substance and I turn it into a new substance. It's something completely new. It's something completely different. Before, with a physical change, if I have paper, I still have paper. It remains the same. A chemical change is when I create something new. Okay? Something completely different. If I take this piece of paper and I light this piece of paper on fire, okay, it forms this black substance. We call this black flaky substance ash. Okay? Ash is completely different from paper. Ash is black, it's flaky, it doesn't resemble paper at all. Okay? It's completely different, has completely different properties. Okay? Also, I know when it's a chemical change and when it's a new substance, when I can't turn it back into its original substance. No matter what I do, I cannot take this paper, once I burn it, once I turn it into ash, I cannot take this paper and turn it, or this ash and turn it back into paper. I cannot reverse this process. That's a pretty good indicator that a chemical change has occurred. Now, there are some indicators of a chemical change. How do I know a chemical change is occurring? First off, if I have a change in color. Okay, again, going back to the paper. I go from white paper to black. That's a color change. Okay, that is a good indicator that a chemical change has occurred. Okay, I've chemically changed the paper. All right. Another example, gases are being given off. Whenever I burn the paper, it produces smoke. Okay, it produces smoke. That's a gas. All right. Gases are being given off. Another example of a chemical change. Now we have to be careful with that though, because here with my boiling water, I have a gas that's being given off, but this is not a chemical change. This is a physical change. And a good way to kind of keep track of that is here I have water, and here I have water. It's still water. I haven't turned it into a new substance. Whereas if it's a chemical change, it is a new substance. Okay. Another example, or indicator if a chemical change has occurred, is if something gets hot or if light is produced. Okay? Again, going back to my paper. Heat is being produced. Heat is given off by the flame. This is a chemical change. Another example is a glow stick. Okay, you guys have all seen glow sticks before. All right. In this case, I have actually two rods. I have an outer plastic rod with a chemical, and I have an inner glass rod with a chemical. When I break the glass rod that's inside of the plastic rod, the two chemicals are allowed to mix, and that will produce a glowing effect which produces light. And I know that's kind of hard to see here, but you guys have all come in contact with glow sticks, I'm sure, at some point, and you know that they'll start to glow. Okay, and this one will probably glow a little bit of a yellow color. Okay, it's producing light. It's a chemical change. Last thing is if something gets cold. This is usually an example when you're talking about a cold pack. Okay, cold packs, you mix cold packs together. If you've ever been in an athletic event or unfortunately been hurt or something like that, you take a cold pack, you break the cold pack, it allows two chemicals to mix, and the cold pack gets obviously from warm to cold. And that's another example of a chemical change. Okay, so here are some other ways to kind of test your knowledge. Is this a physical change or a chemical change? Bread toasting. Physical or chemical? That's a chemical change. You're taking the bread and you're turning it brown, you're turning it into something new. You would not be able to take toasted bread and return it to regular bread. Okay? That's something new. That's a chemical change. What about this? Butter melting. There's a key word right there. Melting. Butter melting is a physical change. I'm simply taking solid butter and I'm turning it into liquid butter. It's still butter. Getting a haircut. Chemical change or physical change? This is a physical change. It's still hair. I'm just making it shorter. Whether it's hair that's on my head or hair that's on the floor, it's still hair. That's physical change. Ice cubes melting. Again, keyword, melting. That is a physical change. Again, I'm simply taking solid ice and turning it into liquid ice. So, this is about chemical and physical changes. Remember that if it's a physical change, that means it's still the same substance. It may be in a different state of matter. It may be in a different size or shape. It's still the same substance. That's physical change. If it's a chemical change, that means I've turned the substance into something new. It's a completely new substance. Usually I cannot reverse that process and turn it back to its original state. Okay, it's something new, like a piece of white paper turning into black ash. It's something new. So, physical stays the same. Chemical, something new. Hope you've enjoyed this video segment over chemical and physical changes. We'll see you next time.